Hey everyone, the topic of the day is Wheatstone Bridge. Actually, what is Wheatstone Bridge in the sense? Let us first see to the definition. It is a device of resistances, and it is used to measure one of the resistances in terms of other three resistances. That is called as Wheatstone Bridge. In the other, we are going to see the topic is the two important laws and its significance, which is very important. Kirchhoff's current law, also called KCL, it states that algebraic sum of current of a node is equal to 0, or it can also be stated as sum of current entering the node is equal to sum of current leaving the node. And diagrammatically it can be represented in this way, like I1 represents the current entering through the junction, and I2 is also entering to the junction, I3 is leaving the junction, I4 is also leaving the junction. I1 is through which a resistance is R1, I2 through which a resistance is R2, like that similarly R3 and R4. So it can be represented like this: I1 plus I2 minus I3 and I4. Why it is minus I3 and minus I4? It's because the two currents are leaving the junction. So finally it can be represented in this way. This is about KCL, Kirchhoff's current law. That is first law, it also stated as. Now coming to its significance. Actually, its significance explains it is according to the law of conservation of charges. And the Kirchhoff's second law is to be called as Kirchhoff's voltage law. It states that the algebraic sum of the I into R, which means the current and the resistant, a product, is equal to the algebraic sum of the EMF present in the various branches of a closed circuit. This is to be called as Kirchhoff's second law, also can be called as KVL, which is represented in the circuit diagram in this way. And it can represent, with the help of the circuit diagram, we can make it an equation in this way. That is I1 R1 plus I2 R2 minus I3 R3. Why is it here minus I3 R3? Means it's because the tracing path is, the current is in the opposite direction of the path which we are tracing. So it is represented as I3 R3, which is equivalent to the EMF, the sum of the EMF. That is what the law states as, which we are representing in the form of equation. It is sum of EMF E1 plus E2. Again E3 is opposite in the tracing path, so it is minus E3. It's easy for us when we remember the laws in terms of equations like this. So once we clearly understand this equation, we can write the law. So make a note of it. And the significance of this KVL is, significance of Kirchhoff's voltage law is, it explains the law of conservation of energy, whereas KCL was, it explains the law of conservation of charges. And a very important difference between a terminal potential difference and EMF. Many of us get confused between these differences. Actually, it can be very clearly understood by these 2 points. Let us start. Terminal potential difference means it is all the potential difference only between the electrodes. The one word makes a difference there. The one word is closed circuit. Whereas the EMF is also the potential difference between the electrodes of cell only, but it is in the open circuit. What does mean by closed circuit and the open circuit? Means closed circuit is the one where the current is drawn from the cell. Whereas open circuit, there is no current drawn from the cell. That is the first and the foremost main difference to be known. And the second difference is it cannot be greater than EMF, which is it terminal potential difference, whereas EMF, it is always greater than terminal potential difference. These are the two prime differences to be remembered in these two parameters, that is terminal potential difference and the EMF. So main thing which makes difference is terminal potential difference is under a closed circuit and this is under a open circuit. So what is open circuit? When no current is drawn from the cell. What do you mean by closed circuit? When the current is drawn from the cell. This is the main difference between the terminal potential difference and the EMF as a whole. You can look at it. And then comes, and also the other point, that is it depends on external resistance, terminal potential difference, whereas EMF, it is independent of external resistance. So terminal potential difference works under closed circuit when current is drawn from the cell, whereas EMF when no current is drawn from the cell, and it cannot be greater than EMF. It is always greater than terminal potential difference. And the one more point is it depends on external resistance and it is independent of external resistance. So the definition of open circuit and the external circuit. This is the main thing, differences between a terminal potential difference and the EMF.